Okay, I'll get the board going. And so we are doing P4. I plan to get it all done, and we're in here until 12:15, right? Is that when lunch goes?
Yeah.
Perfect. So we're doing a little reminding ourselves of our slope, slope-intercept, point slope, all that fun stuff. This is easy stuff, right? This should be a pretty easy day.
Yeah.
Good. Okay, the first thing it says is it wants us to find the slope of line AB. Who remembers the slope formula? Ava.
Y equals
Slope. How do I find slope between 2 points?
Oh, you do the like the y2 minus y1 over the x2 minus x1.
Very
Sorry,
good.
I was thinking of the.
That's okay. There's a lot of different formulas, and I'm going to write down all of them. So I'm just going to remind us them as we go. So the first one is when we find slope, we have to do y2 minus y1 over x2 minus x1. Remember that slope is the same thing as rise over run. And so if you ever forget, oh, does the y or the x go on top? I remember that rise is my vertical distance, which is talking about my y's, so that goes on top, and my run is my horizontal, which is my x's. I hope everybody's with me. This is important stuff. Good. I'm sure we're going to hit the one that you're thinking of momentarily. So I'll just walk you through the first slope one, and then I'll have you try the next one. Some of this is pretty easy, but I do like to remind you, since it's been a minute since you thought about it. We've got x1, y1, and x2, y2. It doesn't truly matter which one goes where, as long as we're consistent. So I'm going to do -1 minus 2 over 7 minus 3. -1 minus 2 is -3, and then 7 minus 3 is -4. Pretty easy. You good? Go ahead and try the next one. Try the next one. Oh, the equation, sorry, right here. y2 minus y1 over x2 minus x1. Okay. You know what, you can even have it. I'm not show it very well, but you can have that if you want it. I'm gonna do the same thing for the next one. I want you to try it if you haven't already. What's that the same thing as Quinn? It would just be 0. I like to pause right there because I want to remind you something. Sometimes we get confused and we're like, okay, 0 on top or 0 on bottom, which one is 0? A trick one of my students told me in the past that they do is they say if you have 0 on top, it's okay. And if you have a 0 on the bottom, it's NO. It's not okay, which means it's undefined. So sometimes I have to remind myself, okay, 0 on top is okay. All right, we're good. So yeah, 0 divided by -13 is the same thing as 0. All right, we're going to use this equation still, but now it says find point B so that the slope of AB is as indicated. So that means I gave you most of your points. I gave you A is 3, 2, I gave you B is 6, Y, and I told you the slope is 2 over 3. That being said, I just don't know what my Y is. I know my x1, I know my y1, I know my x2, and I don't know my y2, so we're going to use y to represent y2. Instead of saying m equals, I can say 2/3, or I guess I could say m equals 2/3, and that's the same thing as my slope equation that I'm going to write. y2 minus y1, so y minus 2 over x2 minus x1, which is 6 over 3. Now I'm going to take this equation and solve it. One step I want to do before I do anything too crazy is just simplify. The bottom, the denominator of the right side can be simplified. So I'm going to think of this as 2 over 3 equals y minus 2 over 3. Okay. Once I get here, how would I solve, Max? times 3 to both sides. You could do that, just multiply by the 3 that's in the denominator over here. Did anyone think of a different way of wording that? Of how we would solve it? Anyone do it different than Max? Yep, cross multiply, right? 2 times 3 and then 3 times y minus 2. Is that what you meant?
No, I was just
Oh, I like that too. Cross multiply is an option. Why are you allowed to just like negate the 3's and just set the numerators equal to each other?
both over 3.
What'd you say, Barrett?
Both over 3.
They're both over 3. If their denominators are both 3, then that means whatever's in the numerator should both be the same as well. So we're allowed to just do 2 equals y minus 2 and solve that. Now, if for some reason you didn't see that or you were worried and you're like, ooh, I don't know if I'm allowed to cross these out, what you can do instead is cross multiply. So we can do 2 times 3 and then 3 times y minus 2, and we'll still get the same answer. I'm just going to solve that one out to prove my point. 3 times y minus 2 equals 2 times 3, which is 6. Multiply, I get 3y minus 6 equals 6. Add 6 to both sides, I get 12, and then divide by 3, I get 4. I can do the exact same thing that Max is telling me. I'll just move this guy over so I can kind of see his work. I can do 2 equals y plus 2, or y minus 2, excuse me, add 2 to both sides, and in way less steps, I still get y equals 4. I had to do all that to find what y was, so point B is 6, 4. We just had to plug 4 in for 6, or 4 in for y. The next one is just like that. Do you think you can start that one without me?
Yeah.
Go. Now in this one, can I just like cross out a numerator or cross out a denominator? No, I'm gonna have to do my long multiplication. That's okay, it'll be fine. -3 times x minus 4 equals 8 times 6, which is 48. Solve. You got x equals -12. Is that what you guys got? Yep. So I would write B is -12, comma -2. Ooh, I did not want to do that. Go back. All right, we doing okay so far? All right, let's look at the next one. This one says, write the point slope form of the line. Okay, now I've got a new equation. Who remembers point slope form? Eva?
Is it the one where it's like y? Is it like the y with the minus y1? And then plus or the minus x minus x1.
Lost something.
Oh, it's the slope. No, I'm sorry.
We're gonna say y minus y1 equals and then m times.
Oh, m times that x minus
X
x.
minus So remember, it's an equation. So I've got the y's on one side and I've got m times the x's on the other side.
That's the one I'm not remembering. I'm sorry.
I actually like this one the best because I think it's really self-explanatory what's going on here. You plug the points in for x1, y1, you plug your slope in for m. Always leave x and y as the variables that they are. Leave them as x, leave them as y. There's no need to plug numbers in for them ever. Okay, so let's do this first. This is point slope form, so I gave you a point and I gave you a slope, and we're gonna plug it in. I don't really want any simplifying because my final answer should be in point slope form. So I'm gonna say y minus y1, which is -2, y minus -2 equals m, which is 6, times x minus x1, which is also 6. The only thing I want you to simplify is I want that minus and negative to be a plus. Everything else is fine. I want you to leave it unmultiplied, unsimplified. This is your best answer. Okay. That's not too bad, right? We can do that. The next one's really similar, except I have to find what first? Slope. You think you can do that without me?
Yeah.
Perfect. Because we're so self-sufficient. All right, I got my slope was 2. Did you guys get your slope to be 2?
Yeah.
Perfect. Did you get one of the 2 equations I have? Does it matter which one you use?
No.
They're both correct, right? So I wrote both down just in case you had one and I had a different one, so you could check your work. If I would give you a question like this on a quiz, like I would have both of these on my answer key because I would be okay with either answer. Okay. Flip your paper over. Now we're talking about the same thing. It's still under the same set of directions. Write the point slope form of the line. So I may actually write my equation up here just in case I forgot, or in case I was worried I would forget. Y minus y1 equals m times x minus x1. And this time it says we want to write that equation of a line that's parallel to x plus 4y equals 10 and contains the point 1, -1. All right, parallel is important to me. Why? Find the slope, and what do I want the slopes to be, Barrett?
Same as the line.
Same as the line. Good, so I need to find the slope in this equation, and I want to use the same slope in that equation in my new equation. How would I go about finding the slope here? Yeah, Max.
You would minus that x over,
Good, minus your x over.
and then you would divide everything by 4.
Good. So I divide everything by 4. So that gives me y equals -1/4 x plus, most simple, that'd be 5/2. Does that 5/2 matter?
No.
No. You could even just like ignore it immediately. Just be like, okay, I knew I had to divide by 4. I only care about this right here. And what's my slope of this equation? Good. And what slope am I going to use in my next equation? -1/4, the exact same thing. All right, we use that slope and the point that they gave us, and we're going to plug it into point slope, and I want you to leave it as point slope. So y minus or plus 1 equals -1/4 x minus 1. That's it. Cool. All right, the next line says perpendicular. Why is that important?
Reciprocal.
Reciprocal. Reciprocal. I need more words than just reciprocal. Opposite reciprocal. Very good. Opposite reciprocal. So just like the last one, figure out what the slope of this equation is, figure out opposite reciprocal, and then come back to me.
So for the new.
Yeah, I said come back to me, not yet.
Sorry.
Patience is a virtue.
Sorry.
It's okay. We don't want to ruin it for everyone else trying to work. right, I found my slope of the line that was given to me to be 1/3. That makes my opposite reciprocal, my perpendicular slope be, even tell me now, -3. Good, and then I used the same point that was given to me earlier, and I just plugged -3 in for my slope. So y minus 7 equals -3x plus 3. Cool, how are we doing with that? Everybody good? Awesome. All right, we're gonna do one more thing. We still got 6 more minutes for lunch. I think we can do the next thing. Basically exactly what we were doing, but now it wants it in slope-intercept form. What is slope-intercept form? Good. If anything else, if anything is tattooed in your brain, it's y equals mx plus b. Am I right? That is up there. We will not forget that. Now, you can do a couple different things, and I'll actually do 2 examples on this first one. I personally like to do it this way. That doesn't make it right. It doesn't make it the best way. It just means this is what Miss White likes. I like to use point slope form. So I like to put my equation in point slope form. Y minus 8 equals 6 times x minus -5. And then I take that and make that into my slope-intercept form. So here I did, okay, that becomes plus 5. Let me distribute my 6. Y minus 8 equals 6x plus 30. And then I'd add 8 to both sides to say y equals 6x plus 38. Great minds think alike. Maggie, question? And yep, that's in my second way that I'm going to do it. So you don't have to think like me. What you could do is you could use y equals mx plus b, and we have y and x and m, and we're going to plug it in to find b. So if I did it this way, my y is 8, so I'd say 8 equals m, which is 6, times x, which is -5, plus b. And I would find out what b is here, and then my last step would just be putting everything in points into slope-intercept. So we would solve it this way: 8 equals -30 plus b. I'd add 30 to both sides, and I get 8 plus 30, which is 38, equals b. And I already know that my slope is m, and if my b is 38, then I would say y equals 6x plus 38. The only thing is you have to remember to put it back in slope-intercept. 38 is not your answer. Y equals 6x plus 38 is your answer. So on all of these, you can do one or the other. As long as your final answer is y equals mx plus b, I do not care how you got this. Okay? So we've got 3 just like the 3 that we did. Do you think you can do those by yourself?
Yeah.
Yes. Okay. I'm going to be quiet. I will have my answers up on the board. I'll zoom in on those in a second. But I will be silent. You work on those and check in with me momentarily. Got my letter B on the board. Check it out. It died on you. Do you like that yellow?
Yeah.
Do you want me to? I have another one like that, I'm sure. Maybe not here, but you want me to bring it for you later? I don't like it. I don't think it writes hard enough. But if you like it, I'll share with you. It's so long. All right, I've got both B and C up on the board. Anybody have any questions on B or C? Stuff by the fractions, or are we like somewhat too good at that? Don't scary though. I'm gonna look at the last one. Now for this last one, my slope is 1/2. What's that opposite reciprocal gonna be? -2. I know I hear people, let's fight through, let's finish this. You can do it. Once we know our slope is -2, you do whatever method you do to figure out what your slope intercept is. You guys get what I got?
Yeah.
All right, yeah, right. I'll leave the answers up. If you're done, you can go to lunch. Be back at 45 and we'll keep going. You're welcome. You're so welcome. All right, we're coming back to this. Now you hit that first slide one more time. Thank you. I'm just trying to, I think we have enough time to finish, but I'm just making sure. You will definitely have enough to do your homework though, so at any point, p.4 is due next class. But I do want to get as much done so you have all the examples possible. Here we go. All right. Oh, actually, I think we're doing great on time. Like rest your back, and I'm like, oh, we can kind of relax. That's all right. The next part is actually using our textbook. So I wasted time last class going to get it, so I don't have to waste time with you guys getting these pictures. But I might put them on the board so you can screenshot them or remind you. Did I tell you your textbook for pre-cal is on Schoology? Oh, yeah. Did I tell you guys in the group? I didn't tell another class. I can't remember if I told you guys. So if you turn to your page, you just have like a bunch of blanks, right? So what happened here is I wanted us to use the book, and I wanted us to go to page 41 and go to number 45. So I'll just jump over there really quick so you can all kind of see it. So if I go to Schoology and go to our page, G period, under materials, it says pre-cal textbook. And sometimes it takes a minute to load because it's like literally 1,000 pages. I do not assign stuff out of the textbook, but it's a really good resource for you if you want to like see what we were learning, want to see more example problems. I think there's answers in the back here. But I went to page 41 and I grabbed these problems from it. Yeah, so I wanted 45, I wanted 46, 47, and then I think I wanted 51. So I just grabbed a handful of these problems from section 2.4. We're still doing linear stuff, we're still using our formulas, but now we're gonna have like word problems with it. I also want you to get your graphing calculator out because we will be doing some graphing calculator stuff as well. So if anything you need, graphing calculator out. If not, you can listen to me. Also, if not, have I talked to you guys about this app called Calculate 84? Yes. Okay. I feel bad. I guess I like don't talk to Al about anything. So I was like, have we talked about this? And they're like, no. And I was like, I'll talk about it with somebody. That must be it. So what happens is Calculate 84 is an app you can have on your phone. It's on your iPad. And when you pull it up, it looks just like a graphing calculator that you might have. You cannot use this on a test or quiz, obviously, but I think it's really nice in homework, or for example, like if you don't have your calculator with you, you can still go through the motions. What I find a lot in pre-cal is that people just like to watch what I do on the board and they're like, oh, I can watch and like learn and observe. At the beginning of the year, we do a lot of stuff with playing with the window. And if you don't have your correct window and you haven't like kind of messed around with it on your own, you're gonna get to a test and you're gonna be confused because your graph won't show up and I can't help you find a window there. So we have to be comfortable doing that stuff. I do feel like Mrs. Luddington and Miss Hollis gave you guys a lot of good practice with that, but I want to kind of reinforce that because I'm sure you did not spend your summer doing graphing calculator problems. Am I right? Yeah. Just thought I assumed, right? So we're gonna use that, not yet. And again, you can take a picture of this, or you can just kind of listen and maybe make a couple notes of things so you know what this problem is asking us later on. This first one's talking about real estate appreciation. So Bob Michaels purchased a home 8 years ago for $42,000. This year it was appraised for $76,500. Okay. Now it says it wants us to write a linear equation, B equals MT plus B, where T is in between 0 and 15, represents the value B of the house for 15 years after it was purchased. Determine M and B. So we're going to use the information above and we're going to find M and B. So it's going to be a linear equation. Do we know either M or B already? No. Okay, great. Let's write some points then. Can we write that we purchased the home 8 years ago for $42,000 as an ordered pair? I'm going to argue that I want you to write it as 0, 42,000. I want 0 to be like the first day or the first year that you bought this house. 8 is going to be 8 years later, the house is now worth this much. So my other point is going to be 8, 67,500. Using those, we can find M and B pretty easily. Don't you agree?
Yeah.
It's the exact same thing we're doing, just a little bit bigger numbers. So I want us to find M and B first. So whatever order, however you want to do it, I want you to go do that now. I'm going to do M first. I got my slope. Did anyone figure out their B yet? I'm actually going to argue we don't have to do any math. We can just look at this and know what B is. Andrew? Good. Why do you think that?
Because it's an order of down, it shows where it's about y-intercept.
Good. That's my y-intercept. If I went 0 left and right on my x and I went up 42,000, that's my y-intercept. Another way to think about it is that's what I'm starting with. 0 years ago, my starting value was 42,000. So like I have to start there, and then everything else I'm going to add on to that incrementally up. So I'm going to write B equals 3,187.5t plus 42,000. That's my answer for my linear equation. Okay. Now this is why we got our graphing calculators up, because the next one says graph the equation and trace to estimate in how many years after purchase this house will be worth $72,500. So in my paper, I'm going to go to the graph, and my answer will be in blank years, the house will be worth. Let's see. I'm looking for $72,500. So especially if you don't have the problem on your paper, I would kind of make note of like, what are we finding? What are we doing? What was the point of this? So we're going to go graph it in the calculator. I cannot show both at the same time anymore. So I'm going to remember this formula and I'm going to go graph it right now. So I'm going to my y equals 317 or 87.5x plus 42,000. Don't lose a decimal place like I just did. Okay. Look at Before I press enter though, I'm gonna go to my window and change that. Window is really the biggest thing that messes us up. If you have your window, and if you haven't changed your window since like last year, it's probably -10, 10, right? On these, we're doing real life situations, so there should be no negative. So both my X-min and my Y-min will both be 0. My X max, did it tell us how big T could be, how big my years could be? $15. So I don't need to go any bigger than 15. So my X, my T is going to be 15. And then my Y is going to be essentially a guess. I need to at least be able to see what's going on. And if I started my house value at 42,000, I at least need to be above that. The number that we're looking for is 71 something. So I'm probably going to put 80,000 in here just so that I know that I can see it. You can definitely do bigger, but I don't want to go so big that then my graph is like this big and I can't read it. So I think that's good. 15, 8,000, 80,000 graph. Okay, perfect. This is all I need to see really. The direction said graph and then it said trace. Do you remember how to trace on your calculator? Physically press the button that says trace and then you just move your arrows left and right. Bless you. Left and right. And I'm going until I can find my Y value to be 71 or 72,500. So I'm at 69 something, 70 something, 71 something. Okay, I hit 72. I hit 72,518. So it's about that. I maybe want that or even lower. So I probably want about 9.5. Is everybody okay with that kind of estimation? 9.5 is going to be my Y value for when my X value, excuse me, for when my Y is 72,500. 9.5 years. The house will be worth 72,500. Okay. Anybody questions yet on the graph or on how I do those numbers? Okay. The next one says, write and solve the equation algebraically to determine how many years after purchase this house will be worth $74,000. Okay, now I'm going to do it algebraically, not in my calculator. This is my equation still. Where am I going to put $74,000? What am I going to replace? Megan? V. Very good. The value. My final answer. I want to know in how many years. So I want to know what T is, which means the V is my number. So I'm going to plug 74,000 in for my V, and I'm going to solve. 74,000. Everything else is the same. And that solving that will tell me after T years when this house will be able to be purchased for that much money. Minus 42,000 from both sides. 32,000. Divide. I got a little over 10, about 10 years. That look good for you guys? The last part of this has one more, and it says determine how many years after purchase this house will be worth 80,250. That's the exact same thing that we were doing. Again, you could graph it. Again, we could do it algebraically. I'm going to do it algebraically very quickly, and then we'll move on to the next one. So 80,250. And I got 12 exactly. Is that what you guys got? Awesome. We love pretty int. All right, cool. So we just did algebraically what we have been doing, finding lines, finding slopes, finding equations. But now we had it with like kind of real life numbers instead of just like random points on a graph. We're gonna do another problem, a little bit different. Everybody ready to move on? This one says Mary Ellen plans to invest $18,000, putting part of the money X into a saving account that pays 5% annually, and the rest into an account that pays 8% annually. Okay, what are the possible values of X in this situation? What's the smallest amount that she could put in a bank, put in one of the accounts? Would you say, sister? Yeah, like 1 cent, right? I'm gonna say 0, and I'm just gonna use a less than sign to say like she can't actually invest 0, but she can like literally invest almost 0. And what's the most she could put in any account? 18,000. Good, the most money that she has. So my X has to be between 0 and 18,000. Okay, if she invests X dollars at 5%, write an equation that describes the total interest I received from both accounts at the end of 1 year. Okay, so I'm gonna write I equals, and I'm gonna have my 5% account plus my 8% account. How do I represent 5%? 0.5. Are we going somewhere?
It's 0.05.
Okay, have fun.
0.05 because it's 5%.
0.05. And it says she invests X dollars at 5%, so we'll say 0.05X. And then 8% is the same idea, 0.08. I'm gonna write an expression now. We could use Y. If we were at a different point of our math journey, we could say, 0.05X plus 0.08Y. But I want to put this all in the equation and solve at one time. How much total could she spend again? How much did she invest? 18,000, and we're not investing X of it because we're keeping X in the other account. So we're gonna say 18,000 minus X is how much she's going to input in the 8% account. So let's work through that. Let's say X was like, 5,000. How much would she have in the 8% account? What'd you say? And how'd you get 13,000? Good. Whatever X is, whatever is in both of these X and then this 18,000 plus or minus X, they together need to add up to 18,000. So it doesn't matter how they're distributed. One's going to be just X, and then the other one's going to be 18,000 minus X. Are we okay with that? That's not such a crazy thought, right? All right, so now we're going to graph and trace to estimate how much she invested at 5% if she earned $1,020 in total interest. Okay, we're going to go back to our calculator and we're going to graph, but we're not going to trace this time. We're going to graph the first one in Y1 and we're going to graph the second one in Y2. And then we're going to find where they intersect. Is that something you remember doing back in Algebra 2? Okay, good. So nothing too crazy yet. Ooh, not what I wanted. All right, so Y1, I'm going to put my 0.05X plus 0.08, 18,000 minus X. The biggest mistake is make sure that you have all your zeros, make sure you got minuses, make sure you have your decimals put in correctly. It's really easy to input something wrong. And then my X or my Y2 is going to be 1,020. And another reason I like this calculator is it gives me colors on my line so I can see exactly what color each one is. Before you press graph, let's go to our window. Does anybody have any questions yet? Everybody's with me still? Okay. I know this isn't super interesting, but I promise it's helpful. Go to our window. Earlier we talked about our X's. What was the biggest X we said that we could input in any account? 18,000. That's a huge X, 18,000, but we need to go all the way from 0 to 18,000 because we could invest anywhere in there in either account. My Y max, that was a little bit more confusing. Remember that our Y2 that we put in was 1,020. I need at least 1,020, if not more. I might do like, I don't know, 3,000 to kind of see where we're at. Make sure that I can for sure see that 1,020, but not too much bigger, or else it'll be like a really tiny graph. So I'd argue on these two graphs that we've done, the X has been a for sure. We always know what that X max is. The Y is one that we kind of have to make up based on what we know about this. All right, let's graph. All right, this is what I see. Everybody good on your end? Okay. So now we want to see where they intersect. Can anyone remind me, how do we find the intersection? Ava?
I put trace and then 5 is the and then
I just hit trace and nothing's coming up.
I did trace and put it, but if you have to intersect.
Did you just hit trace? Does anybody else know what else we need to hit?
Second trace?
Second trace, right, Ryan? Second trace. Now my menu comes up. But if you just press trace, it just.
I did that automatically.
Well, I don't remember that. You gotta help me out.
Sorry.
Second trace. Now I can find intersect. That's what you press, right?
Yeah. Sorry.
That's okay. Now I don't know if you can see my little cursor, little Spider-Man things on there. You have to do something left bound and something right bound. So I did something left of it. Okay, great. Something to the right of it. Okay, great. And mine's going to show me a little purple box that they intersect at. The intersection is at x equals 14,000 and y equals 1,020. That's exactly what I wanted my y to be. The important information I pull from here is my x. The x value here, my x is going to be 14,000. And that's the amount of money in my 5% account. If I'm investing 14,000 in the 5% account, how much am I investing in my 8% account? 4,000. All right, we're gonna pause on D because I'm gonna remind myself how to generate a table and then get back to you on that. So we'll get D next class. Okay. We got 2 more problems and we got 9 more minutes. We doing okay? Okay, I'm gonna move on. We'll come back to D later. Okay, number 9, it says a commercial jet airplane climbs at takeoff with a slope of 3/8. How far in the horizontal direction will the airplane fly to reach an altitude of 12,000 feet above the takeoff? All right, let me draw like a little picture. This is where we started. This is where we go. The slope of this line is 3/8. We want to know how far horizontally we went. But I know vertically I went 12,000 feet. Y equals mx plus b. And what do I do with that? Okay. And how's that going to help us find x? Yeah.
Can you just divide 12,000 by 3 and divide by 8?
I like that. Can we put it in a different way? Why are we going to do 12,000? Would you say times what?
Over 3 times 8.
Why do we get to do that?
Because it goes, 3 goes over 8.
Okay. 3/8 is my slope, right? And slope is the same thing as rise over run. What is my rise in this problem? How high is the airplane rising? 12,000. And we don't know how far we're running. That's what I'm asking us. We want to know that number. In the long story short, we can do exactly what you said, but mathematically what happens is I can set my slope up equal to that because I know how far up and down I went. I just want to know total how far left and right I'm going to go. So when I see it like this, I can do a cross multiplication, which is 3 times x equals 8 times 12, which I believe is 96,000. And then we divide that by 3, which is the exact same math as this. I believe x equals 32,000. But I like what you were thinking, and when I was looking at this earlier, I was trying to think of it in that way, but I couldn't connect them in a way to find what that X was. So I'm sure if I thought about that longer, I could kind of bring it back to that. But I think this is the easiest way to think about it. Okay. All right, I've got one more problem. Are you ready? This one's actually a lot more like the first one or two. This time I give a little chart. This is Americans' personal consumption expenditures from 1998 to 2003 in trillions of dollars. So my X is what? What unit is my X on top? Years. And then my bottom is expenditures, or we can think of it in terms of dollars. So I like to kind of know what's my X and my Y. That will come up later on. It says write a linear equation for America's spending Y in terms of the year X using the points 1998, 5.9, and 1999, 6.3. We can write a Y equals MX plus B equation from that, right?
Yeah.
All right, go. Do it. I might rewrite the points, especially if I don't have this picture on my paper. In order for us to all get the same equation, though, I did have to give you these points. If I just gave you the table, I said find an equation, we might all have different equations. Whenever we do problems like this, we often get pretty ugly numbers. So don't worry, don't second guess yourself if you're like, why did I get negative 700, blah, blah, blah. It's because I'm talking about trillions of dollars and my unit is the years, which I know 1998 looks like a year to us, but that's really 1,998. That's a huge number. Even if you use the other point for your final equation writing, you should get the same thing I did. Is everybody okay with that, writing the equation of a line? All right, then it says use the equation in A to estimate America's expenditures in 2002. And then the next problem says almost the exact same thing to predict it in 2006. We're just gonna pick one year. Which year do you wanna do, 2002, 2006? You don't have a personal preference?
Okay.
Which one, 04? Okay, we're gonna do 04, so we're not gonna do either of those. We're gonna do 2004. And where does 2004 go? Well, I go for my X and my Y when I plug it in to solve. Goes for where? Why X, Ryan? Because it's the year. We already talked about how the year was my X's. All my X's are in years. So if I have a year 2004, that has to go in for my X in order to do this correctly. You'd be shocked how many people put it in for Y and then just get some crazy answer. So really make sure when you do problems like this, you read what is being asked of me. So I'm gonna go plug 2004 in for my X and I'm gonna figure out what Y is. Y equals 0.4 times 2004 minus, I think it was 793.2. All we have to do is simplify it to get Y. 0.4 times 2004. I get 801.6 minus 793.3. And I get 8.3. Which makes sense because that's in trillions of dollars. Makes sense because it's in trillions of dollars. Okay. We're not going to do a scatter plot, but I will figure out what the table is, and we'll talk about that next class tomorrow. I think though that we've done everything we need to, so we can have our P4 homework due is next class. All right, guys, we rocked that. I was worried we'd have to hustle a little bit more, but I didn't think we were rushing. P4 is due next class, which I believe is tomorrow, am I correct?
Yeah.
Yes, 2 days of pre-calc in a row. All right, let me turn this off.